Good morning. I would like to talk about the relation. The subject of my talk is how the relation has helped us and its uses. I'm going to divide my topic in four parts. First, I'm going to talk about the relation and the history of it. I'm going to describe her uses starting in the use of chemical energy. Next, I'm going to talk about natural accidents and finally failure experiments. Okay, moving on now to the definition and history of the radioactivity. What is the radiation? The radioactivity is the emission of energy and particles in the decomposition of atoms. We have some types of radiation, alpha, beta, gamma, and neutrons, and I'm going to explain this in the next presentations. Okay, the history. The history starts when Anthony Henry, in the picture of the left, was the first person to discover this. She saw that some particles emit light and some of both when he accidentally mixed some particles of uranium and potassium sulfate, and he saw that the uranium emits light without the need to be excited. This is a very new concept because the energy could have a lot of uses, but it was very dangerous in this epoch because the humanity don't know about the dangers of this. It's very new. Okay, in 1996, the human started to feel and investigate the secondary effects of radiation. Nikola Tesla talked about this when he suffered burns when he holding an X-ray, but he think that it was for the ozone in the atmosphere. Uh, okay, it was very sad. Moving on now to the atomic bomb. Uh, in the decade of 14, we started to understand the dangers of radiation when uh, United States put the atomic bomb in Japan, and a lot of people suffered poisoning, and some scientists predict the age of the deaths of the people, and today it is happening with a great accuracy. It changed the humanity forever. Nobody knows about the power of the radioactive reactions, and it was shocking when the people see the destruction of this weapon. Okay, moving now to the types of radiation. Uh, we have four types: alpha, beta, gamma, and neutrons. And I'm going to explain this. Okay, the first is the alpha. It occurs when two protons and neutrons are related from particle and they forming helium. Beta. It occurs when a particle releases electrons and antineutrons. This chart illustrates this. The first is the alpha radiation. We can stop it with a paper. The second is the beta. We can stop it this with aluminum. And okay, the third reaction is the gamma. Uh, this is very dangerous in high quantities, but this is used in the hospitals to the X-ray. We can stop it with a little bulb. Uh, and the final is the neutron. This is very dangerous. It's the radiation of atomic bombs, and it's very dangerous because it's made that a reaction in domino effect start, and we can control it with water and concrete, but it can last for a lot of 100 years. Okay, moving on now to the chemical energy. Probably this is a lot of use of the radioactivity. For example, the nuclear energy is very used in these years because it can do a lot of energy. We have some things of this. The first step is the fusion. The fusion, the picture of the left, is when two atoms are combined to form an atom that it's more big, and in the reaction we can get a lot of energy. And the second is the fission. The atoms divide and form other atoms that are more little and has more stability and it to generate a lot of energy. Natural accidents. Okay, uh, an accident that is very famous is the accident of Chernobyl. In 1986, a reactor of the plant Chernobyl suffers an explosion and it's irradiated a lot of places around and killed 4,000 people. Actually, the radiation is very high, but a wall of concrete was built in the area and expected that this wall can contain the radiation for the next 100 years. Okay, the core of the devil. In the Second World War, a scientifics worked in the labs of United States in Nuevo Mexico with a gallium, plutonium, and sphere. The experiment consists in put the sphere in the core of plutonium to deflect neutrons and take it to the limit of critical point to start a nuclear reaction. Harry Dengler was the first victim of this. He got a lethal dose of radiation and he died at 25 days. This chart illustrates how was the experiment consists in a sphere of that puts on a plutonium core. And the second person that died for this experiment was the scientific Louis Slotin. He put a screwdriver to hold the sphere and leave enough space to the neutrons could escape, but the screwdriver accidentally slipped and it started a mortal reaction. Another scientific that too was here said that in this moment they see a blue light flash in a room. Slotin removed very fast the sphere, but it was too late. They have a mortal reaction in his body, and he died at 9 days. Okay, to conclude, the radioactivity is one of the greatest discoveries of the humanity that humanity made for the utilities and for the disaster that it made. Does anyone have any question or comments? Is that clear? Okay, thank you.